The first topic of this module explains where to collect sediment samples and why it is important to find fine sediments so we can learn about the worst-case scenario of sediment contamination. The other topics in this module will walk you through the preparation, sampling, and handling procedures. Click on a topic to start, or click the Next button to see them in order. Welcome to the sediment sampling module. As you know, sediments should not be disturbed prior to sampling. Therefore, other field activities should be performed downstream of your sediment sampling location. Because it's very important to collect water samples immediately after field measurements, it is recommended that you do the sediment sampling later. In any case, be sure to identify the areas of fine sediments first, and avoid waiting in these areas. Click on a topic to start, or click the Next button to see them in order. The purpose of sediment sampling is to find the area where pollution occurs. Many of the chemical constituents of concern are absorbed onto fine particles. One of the major objectives in selecting a sample site, and in actually collecting the sample while on site, is to obtain recently deposited fine sediment. Avoid sand, hard clay, bank deposits, gravel, disturbed or filled areas. Any sediment that resists being scooped is probably not recently deposited fine sediment material. In following this guidance, the collection of sediment is purposefully being biased for fine materials. This must be discussed thoroughly in any subsequent interpretive reporting of the data in regards to representation of the collected sample to the environment from which it was collected. The pictures on your screen show 4 different stream channels with different sediment composition, including fine sediment, sand, and cobbles. You can click on any of the pictures to see them enlarged. Choose a sampling site with lower hydrologic energy, such as the inner or depositional side of bends or eddies, where the water movement may be slower. Reservoirs and estuaries are generally deposition environments as well. See Appendix D of the Swamp Quality Assurance Management Plan for more specific guidance, and click on the video button to view an example of how to find fine sediment in a stream bed. Please note that swamp crews always use areas where they can collect the sediments underwater, not even on a recently exposed muddy bank. Check with your project leader to see if this applies to your efforts.
When trying to find a desired place to collect sediment, we're looking for areas with fine grains that have recently been deposited. In this stream, the dominant substrate is rock and bedrock, which makes it difficult to find fine sediment. As you can see in this channel, which is the main channel, there is somewhat of a flow, makes it difficult to carry fine sediment. As we look to the left, we find a log jam that has slowed down the flow, and a side pull off the log jam with little or no flow, which is a good place for depositional fine sediment.
This graph is an example of total phosphorus in sediment versus grain size fraction, or percentage of sand. As you can see, the total phosphorus decreases as the percentage of sand increases. The fine fraction represents the worst-case scenario in terms of pollutant concentrations. Swamp protocols require that the samplers collect only fine sediment, preferably recently deposited fine sediment, to be consistent in representation of the worst-case scenario for each and every sampling reach. Click on a topic to start, or click the Next button to see them in order. There are many different types of sample jars for specific analytes, but all of them have one thing in common. They have a wide mouth. The analyses being performed dictate the volumes of sediment necessary from each site, as well as the types of containers, any specific collection techniques, and quality assurance or quality control requirements such as preservatives, homogenizing, aliquoting, cooling, and so on. Before you obtain jars, check out the specification tables for sample containers, volumes, initial preservation, and holding time recommendations for sediment samples. These are found in Appendix D of the Quality Assurance Management Plan under Sediment Sample Handling Requirements, as well as in Appendix C of the Quality Assurance Management Plan. For the swamp labeling method, label each container with the station ID code, project ID, event type, analyte, and date and time of collection. In most cases, these containers will be pre-labeled. Check with the swamp database team to determine the correct entries if needed, and feel free to add the matrix type and possibly other descriptors if you want. Prior to sampling, secure the label by taping around the bottle with clear packaging tape. If you are not delivering your samples to the swamp laboratories, check out the requirements of your lab and data tracking system. They may ask that you use their labels to facilitate the sample tracking on their end. At a minimum, record your own station ID or sample ID if it includes the station already, as well as the sampling date and time on the label. Click on a topic to start, or click the Next button to see them in order. Sediment chemistry samples give information regarding both trends in contaminant loading and the potential for adverse effects on settlement and aquatic biota. In order to compare samples over time and from site to site, they must be collected from areas of fine particles and, if possible, by the same method in a consistent manner. Please note that some swamp crews use inundated areas, where they can collect the sediments underwater, not even from a recently exposed muddy bank. Check with your project leader to see whether this applies to your efforts. If a suitable site for collecting sediments cannot be found at a station, sampling personnel should not collect the sediment sample, and should instead attempt to reschedule the sample collection. If this is not possible, make a note so that the missing sample is accounted for in the reconciliation of monitoring events during preparation of sample collection cruise reports. Sites that are routinely difficult to collect should be considered for relocation or elimination from the sample schedule if appropriate. The preferred way to collect stream sediment is by using a coring device, for example, a hand core made of a narrow cylinder with a beveled bottom. However, the use of a hand core is limited to places where there is fine sediment in a layer that can be captured. The hand core sampler used by some swamp crews in wadable streams consists of a 3-inch diameter polycarbonate core that is 8 inches long. Samplers push the core into the sediment to the desired depth. Pull the core out of the sediment by placing their hand underneath the cylinder to hold the sediment in place, or by capping the bottom with a polyethylene core cap. Hand cores are usually measured and marked at 2 centimeters, so the sampler knows how far to deploy the core into the sediment. Sediment is then emptied into a homogenizing jug. To avoid disturbing possible sediment collection subsites, survey the sampling area for appropriate fine sediment depositional areas before stepping into the stream. The goal is to collect the top 2 centimeters of recently deposited fine sediment only. Wear clean gloves for each station. In areas of potential exposure hazards, wear protective gear, and make sure that your gloves are long enough to prevent water from overflowing into them while submerging the scoop. Carefully enter the stream and start sampling at the closest appropriate reach, making sure that you lift the scoop very carefully to avoid loss of fine sediment, and tilt it upwards when draining the excess water to avoid external runoff entering the scoop. You will need many scoops of sediment for most samples. Continue sampling upstream. Never advance downstream, as this could lead to sampling disturbed sediment. If you cannot see the bottom, do not use the scoop method. Try to use a grab instead, or come back later after the water has cleared up. Click the button to view a demonstration of the scoop method.
For sediment collection, we found a desired spot that has fine sediment with a silt clay grain size fraction. And now, ideally, we want to estimate the top 2 centimeters of the sediment, and we're collecting it here in a homogenizing jug. For later, we will aliquot into smaller jars. So what I'm going to do is take my scoop that's been cleaned in the laboratory. I'm going to place it down. I'm going to find an area that has very good sediment. my scoop along the bottom, scooping at the top 2 centimeters. Slowly pull it back up out of the water. I will let all of the surface water or overlying water that was on top of the sediment drain off, and I will want to keep all the pore water that was in the sediment in the scoop, and then I will dump that into the homogenizing jug and repeat this process until I have filled up the desired amount of sediment that I want for all of the smaller jars that I want to aliquot into. I will let all the overlying water drain off. Put my sediment in the homogenizing jug. And while you're sediment sampling, you should be directing your scoop towards the finest sediment that you can find. Silk clay, the finer the particles, the better. If you're looking for contaminants, almost all the time you're going to find them in the finest particles that you can find. Again, we drain the overlying water off the back of the scoop, dump the sediment into the homogenizing jug, and I'll keep looking for areas of fine sediment and direct my scoop towards those areas. I'll pull out any large twigs or branches or leaves. Good.
The Eckman grab shown is 0.2 square meters in size, with a brass messenger that triggers the spring-loaded doors. The primary use is for sampling from bridges, or from small vessels in streams, or drainage channels too deep or steep to wade into, but too shallow for a larger boat. The grab must be decontaminated before sampling and in between sampling stations. There are various sizes of Eckman grabs available. The size limiting factor is the ability to lower and raise the grab. Some Eckman grabs are connected to a long pole that allows for driving them into the sediment while open, and for closing them with a special mechanism when they reach the desired depth. To deploy the grab, pull the spring-loaded doors open and hook the cables on the actuator plate. Make sure the end of the rope is secured, and then lower the grab to the desired sample reach, making sure that the grab has penetrated the sediment. Clip the messenger on the rope and release it while maintaining tension on the rope. The messenger will not trigger the actuator plate if there is too much angle on the line. Therefore, it cannot be used in areas with swift currents. Once the messenger has activated the doors, pull the grab very slowly and let it drain before you bring it back up. Then place the full grab in a large bin and go to step 5 ahead. While wearing clean poly gloves, open the top hatch and remove the top 2 centimeters of sediment with a clean polyethylene scoop. Place the sediment into the homogenizing jug and repeat the sampling process until there is enough desired sediment. If you deploy the grab multiple times, try to move to a fresh spot each time, even if you cannot see the bottom. Please note that compositing multiple grabs will increase the representativeness of your samples, and that is a good thing. Once you have collected enough sediment from the top 2 centimeters in the 4-liter compositing or homogenizing glass container, you are ready to mix your sample. This can be done at your station or on the tailgate of your truck. Do not shake the jar to mix it. Shaking will not homogenize effectively and may introduce too much air, which can alter sediment properties. Use a polyethylene scoop to stir the sediment for at least 5 minutes, making sure that all sediment is completely homogenized. If your homogenization jar is made of glass, make sure that you don't break your container while homogenizing. You have already verified that you have the right kind of sample jars in terms of materials, cap lining, pre-cleaning procedures, and volume. Now make sure your jars are ready for the mud. All sample labeling and identification information has to be recorded and taped onto the sample jars prior to aliquoting. Transfer the homogenized sediment into all the jars. For better representation of the size fractions in the aliquots, organize all the jars you want to fill from this homogenate in a row and add the scoops of sediment incrementally, 1 scoop per jar, then start the round again. This way you ensure that all the jars are filled at the same time and get the same composition of sand and mud. It is a good thing to have a tray and use it in the field to lay out the open jars and their upside-down lids. Clean the threads of the jar thoroughly before you close them. Remember that sand in the thread will allow for leaks, and this can cause contamination both of your samples and of your cooler. Inspect each individual sediment jar, making sure of consistent grain size throughout the entire sample collection. Make sure that all containers are capped tightly and stored in a cooler on cube ice at 4 degrees Celsius. Click on the button to view a demonstration of sediment homogenization and aliquoting.
After we've collected the desired sediment that we want, we then will homogenize the sediment to make sure it's well mixed and then equally aliquot into the sample jars. To do that, we will properly stir the sediment. Making sure to get everything off the bottom, off the sides, and trying to homogenize as much as possible. And we have to remember that we have to act quickly as soon as we start aliquoting to sample jars, as the finer stuff will start to settle out as soon as we stop stirring. And then get our sample jars ready. And we'll aliquot in small increments to however many jars that we have. You never want to fill one jar up completely at one time and then move on to the next jar. The best strategy is to aliquot in small increments to every sample jar. As you can see, we have well mixed mud. I'll pour a small amount to the first one, stirring every time in between each aliquot. And I will try to prevent any sediment from getting onto the threads of the jars. It causes problems when you want to put the cap back on the jar. It doesn't seal properly. We'll then inspect the threads of the jar to make sure that there's no sediment on them. This one looks pretty good. Put the cap back on. This one looks good also. Put the cap back on. We want to inspect each jar, making sure that they look homogeneous and equal to each other. These look pretty good. Samples go on ice. Homogenization and aliquoting is complete. Another form of sediment homogenization and aliquoting that you can use is a glass bowl. This can help with homogenization a little, and aliquoting. It can make things a little more easier. You don't have the smaller hole of the jug to scoop out of to aliquot into smaller jars, to where you can stir and scoop and aliquot a lot easier from the bowl to smaller jars.
Safety precautions are important when collecting samples, especially samples that are suspected to contain hazardous substances, bacteria, or viruses. Proper gloves must be worn to prevent contamination of the sample and to protect the sampler from environmental hazards. Disposable polyethylene, nitrile, or non-talc latex gloves are recommended. Please make sure that you are using the correct material for your situation. Wear at least one layer of gloves, but 2 layers help protect against leaks. 1 layer of shoulder-high gloves worn as the first or inside layer is recommended to have the best protection for the sampler. Tyvek suits with goggles and face masks are also worn to prevent any water contact with the sampler's skin. All sampling gear suspected of touching contaminated water should be properly disposed of or spray washed with a 10% bleach solution. See Appendix H of the Quality Assurance Management Plan for detailed safety precautions. Properly store and chill samples as soon as possible. Sufficient ice will be needed to lower the sample temperature to at least 4 degrees Celsius minutes after time of collection. Care should be taken at all times during sample collection, handling, and transport to prevent exposure of the sample to direct sunlight. See details of storage requirements for bed sediment samples in the Swamp Quality Assurance Management Plan. The toughest quality assurance or quality control issue in sediment sampling is keeping everything clean. The problem is that you cannot collect sediment blanks because there is no such thing as clean sediment. What you can and must do is decontaminate and decontaminate again. Collect rinse blanks and make sure that your jars don't leak. Look at the equipment decontamination procedures in the Swamp Standard Operating Procedures and make sure that you have the right detergent. You must use one that does not leave any residue, such as micro, alkanox, or liquinox. Bring enough scoops and jugs to the field so that you can have a fresh, lab-cleaned set for each station. If you use a sampler such as an Eckman, decontaminate thoroughly between stations and again at the end of the day. Then rinse it with clean water and collect the rinsate. This rinsate will be analyzed for the same analytes as the sediment samples. Field duplicates are collected using the same sampling techniques except for an increased volume of the sediment sample. If possible, collect enough sediment into the homogenizing jug to properly fill enough sample jars for the sample station and the sample duplicate. Duplicates, except for toxicity, are currently submitted at a rate of 5% per sample event. Data quality is also about the usability of data, and usable data must have good and known representativeness. You already know that sediments can be very patchy in nature, and that compositing several scoops, cores, or grabs from the same station will increase representativeness. The user of your data will assume that a jar that went to lab X has the same content as the jar that went to lab Y if they come from the same homogenate, so please homogenize well and aliquot in increments to make it true.